Project 121, Draw an Alarm, uses the same circuit, but we are going to put the ends of the wires on this black square. Now this may be a little bit tricky doing it with, now that's just my fingers touching. And look at that. I'm not touching the ends of the wires, but the alarm is sounding. That's because I filled this area in with a pencil. The lead of a pencil does conduct electricity. And the lead used in this type of writing tool is actually graphite. It's used to limit current, but it will conduct it if it is thick enough. You may have to draw hard and fill the shape several times. You want to make sure you don't rip the paper, but you may need to do it several times so that it is conductive enough to power the alarm. Project 125 is called Yellow and More. This project is relatively simple, although it has an interesting explanation. As you can see, I included the disco motor and the bicolor LED, and it is adjusted so that the yellow one will come on. When I turn on the switch, the bicolor LED lights up, and 2 of the 3 LEDs on the disco motor, the red and green ones, come on. That is because the electric current flows from the batteries through the yellow LED, and then it divides among the LEDs on the disco motor before flowing through the slide switch and back to the batteries. As I have explained several times in previous projects, the blue LED on the disco motor is either very dim or off because it requires the most current. The red LED requires the least current to function, so it is brighter. The green LED is in the middle, but there's not enough to light it fully. 126 is called Red and More. You have to either reverse the connection of the bicolor LED or replace it with the red LED. I'm going to turn on the slide switch. Now the red LED is on, and then the 2 LEDs on the disco motor also light. So the only difference is that the LED is red, the main LED is red instead of yellow. Now for 127, Green and More, I will replace the yellow LED with the green LED. I'm not going to turn the switch off, but I am going to put the green LED in its place, and you get the same result. Now the green LED requires more voltage to turn on than yellow or red, so the lights on the disco motor may be even dimmer. Project 128 is called Random Siren Selector. For this project, I have included the U29 module, and what we need to do is turn on the slide switch. Now the fire engine siren sounds, but we have to select game 1 and hit the B button. Now the siren will cycle through the different tones every few seconds. There's one of 3 available tones for this circuit. You can probably guess what they are: the fire engine siren, the European siren, and the machine gun. The U29 display also shows a random pattern. Now, as part of Project 129, fast random Siren Selector, we can select either Game 2 or Game 3, which I am going to do. Turn the slide switch off to reset. I'm going to select Game 3. Pretty funny combination of sounds that you hear. And the changing display on the U29 module adds to the fun. Project 130 is LED Random Siren Selector. I have added the speaker, I have moved the speaker and have added two LEDs, the red and bicolor ones. I'm going to turn on the slide switch and select Game 1. And it should kick in. Yep. The sound is far more quiet. That is because the LEDs are using more energy. And therefore the speaker cannot receive as much. The LEDs also flash because the alarm integrated circuit is controlling the current. At least with the machine gun sound. 131 is called 5 LED Random Siren Selector. I added the disco motor now in addition to the two other LEDs. And when I turn on the slide switch, all the LEDs will light up and the siren will sound. But when I select, I'm going to do Game 2 this time, the components will activate in a random sequence. Like the disco motor lights up. I don't think it actually spins, but it lights up. The siren tone changes, the LEDs flash, and the U29 display changes. In this circuit, the disco motor LEDs are pretty bright. Project 132 is Disco Arcade Show. Now, I don't have the shaft for the disco cover available to mount it, so I cannot give a light show, but I can show you the basic principle. We turn on the slide switch and select Game 1 and hit the B button. Now, it should kick in. Alright, here we go. The speaker will make random noises, the LEDs will turn on and off, and the disco motor will spin and light up. The display pattern should also change. Now, the blue LED on the disco motor does not come on, probably because the other components are using a lot of the current from the batteries, and since the blue LED requires the most current, it's not going to be at all bright. I like what the display is doing now. The numbers are like fading in and fading out, just like that. .133 is called Fast Disco Arcade Show. We're going to select either Game 2 or Game 3. I'm going to do Game 2. And now all the actions will occur faster. The display will change at a higher rate, as will the sounding of the speaker, the switching of the LEDs on and off, and the spinning and stopping of the disco motor. Now, if I had the disco cover available and I was in a darker area, you could see the light show on the ceiling turning on and off at random intervals. .134 is called Word Fan Arcade Show. As you can see, I replaced the disco motor with the programmable fan, and I moved the bicolor LED to the left. We're going to select Game 1, like we do for these other types of projects. And now, instead of the disco motor coming on, the programmable fan will turn on and light up. You can see the first message on the fan, which is just the number 6. And in addition to the fan spinning, the speaker will play different tones, the LEDs will turn on and off, and the display changes. But I'm going to focus more on the fan because that's the main principle of this project. Now, it probably won't stay on long enough to see the other messages that are on it, but you can at least get an idea of how it will act in this project. Now, this was the case for Project 132, but there are alternative connections for the speaker if you want the sounds to be a little bit louder. They're not going to be as loud because of the other components using the current from the batteries. So, it's up to you. I'm not going to do it, but if you want to, you can just refer to the instructions on how to hook up the speaker so that the sound is better. 135 is Fast Word Arcade Show. We use the same circuit, but I'm going to you either select game 2 or 3. I'm going to do 3 and hit the B button. Now, all the components turn on and off in faster intervals. And now the motor is spinning so fast, the fan is turning on and off so rapidly that it may not display any messages. At most, it will only display the first message. Yep, you just saw the number 6 briefly. Project 136 is Light Projecting Arcade Show. As you can see, I have included the disco motor and the programmable fan. And we will turn on the slide switch. The programmable fan will spin, and the disco motor will also rotate and light up. But we are going to select game 1 and see what happens. The circuit will perform a lot of different actions, including the programmable fan spinning on and off, and the disco motor and its lights coming on and going off. Now in this circuit, the blue, all 3 disco motor LEDs are on at full brightness. There is enough current to go around. The transistors, I think, help to increase the current so that it is strong enough. .137 is Fast Light Projecting Arcade Show. We will select either game 2 or 3. I am going to do 3. And now everything switches a lot faster. Project 138 is Where's the Blue Light? As you can see, I included the disco motor plus all 3 regular LEDs in this project. I am going to turn on the slide switch to see what will happen. You can see that the 3 main LEDs and 2 of the LEDs on the disco motor are at full brightness, but the blue LED is very dim, and from a distance it may appear to be off. Mr. Snappy says that the voltage is split and between 2 groups of LEDs, and the blue LED requires more voltage, so that's why it's barely lit. Project 139 is There's the Blue Light. Well, I added the press switch to the circuit, connecting it between the slide switch and 4-snap wire. Turn on the slide switch, and all the LEDs except for the blue one are at full brightness, but push the press switch, and now all 3 LEDs on the disco motor are at full brightness, but the 3 main ones are off. Let go of the press switch, and the 3 main LEDs come back onto full brightness while the blue LED becomes very dim. And maybe actually the 2 other LEDs on the disco motor are not as bright as they normally would be. But the reason why the 3 LEDs on the disco motor reach full brightness upon hitting the press switch and the others turn off is because all the energy from the batteries is now concentrated to the LEDs on the disco motor. When you hold down the press switch, you cut off power to the other 3 LEDs so they cannot operate. But when you release the press switch, now current can flow to more components within this circuit, and therefore the LEDs on the disco motor will not receive as much, so they're not going to be as bright. Project 140 is No Blue Light. Like the previous circuit project, I'm using the press switch, but this time I connected it between these 2 points. I'm going to turn on the slide switch, and when I hit the press switch, watch what happens. All 3 LEDs on the disco motor turn off, while the 3 main LEDs reach full brightness. And that is because, like with the previous project, I'm cutting off electricity to a certain part of the circuit. In this case, it's the disco motor, not the main LEDs. Now, all the power can be distributed within them, so they will be a lot brighter. When I release the press switch, the current can flow to the rest of the circuit now. Project 141, called Dim Green Light, is pretty interesting. What we will do is use the Project 138 circuit, which excludes the press switch, and we will remove 2 of the 3 LEDs in various combinations shown below. There are 4 combinations. And now the red LED is D1, the green LED is D2, and the bicolor LED is D10. Now we will have to observe the LEDs on the disco motor and see how they respond to the removal of certain LEDs. First, we will remove the green and bicolor LEDs. Watch carefully. Now only the red LED is operating, and it seems like there's really no difference in the brightness of the lights on the disco motor. Now we will reinsert the green LED, but take out the red LED. Now, because the green LED uses more energy, the red and green lights on the disco motor are even dimmer, and I think the blue LED is off, or ever so dim. The third combination is having the bicolor LED on but removing the green LED. The result, I think, is similar to that of when you have just the green LED operating. Now, we are going to turn the D10 LED around, and now it is red. The lights on the disco motor may be a little bit brighter because the red LED does not use as much current. And so now you have a better idea of how the combination of components in a circuit that are receiving electricity can interfere with the performance of existing ones.